So the last section we're going to look at this week, different than conics. Okay, it's on solving systems of equations. When you're solving a system, it generally implies you're solving for a minimum of how many variables? Two, right? Systems generally mean you're solving for a minimum of 2 variables. And that's what we're going to start with. 2 equations, 2 variables. Also, when we solve systems, those 2 things are going to be the same. The number of equations I give you and the number of letters I have you solve for. So if I'm giving you 3 letters to solve for, I'll give you 3 equations. 2 letters, 2 equations. If you don't have the same number of equations as variables you're solving for, then interesting things start to happen. You either have what's called an overdetermined or underdetermined system. All right. For example, if I gave you this, and I said solve it, well, that's 1 equation, but I gave you 2 letters. That's underdetermined. What that means is there's going to be an infinite amount of solutions. Right? Basically, any point that's on the line, y equals 3x plus 2, is an answer to that equation. If I gave you a second equation to go with it, like another line, then we could look for where they cross, and there would only be 1 solution. Right? Now, kind of the opposite case, if I gave you 3 equations, and I said, here's 2 letters to solve for. Unless it works out very special, 3 equations that are lines could look something like this. Do all 3 ever cross at the same spot?
No.
No. So then it's impossible, unless you have all 3, like in a very special situation, crossing at the same spot. You can't solve a system that has more equations than you have variables, usually. The only way that works is if one of the equations they gave you could be like a repeat, it's not really a different equation, or it works out really special, where they all cross in the same spot. All right, so we're going to focus on 2 equation, 2 variable. That's kind of what we're going to start out with. There's different methods. Okay, for solving systems, we're going to go through 2 methods, and then we'll see which method is better, depending on how many variables you need to solve for. Yep.
Are we going to be doing any graphing calculator for like this stuff to like show our final answers or anything?
No, we're not going to do graphing, but you do need to kind of understand the concept of if you had 2 lines and you graph them, that the intersection point is the solution to the system. That concept is very important. Okay, so this basically gives us a rectangle. It says the perimeter is 100, the area is 300. Find the length and the width. Okay. What's the formula for the perimeter of a rectangle? Yep.
Length plus width equals perimeter.
Length plus width equals perimeter.
Length plus, or 2L plus 2W.
2L plus 2W equals perimeter. Okay, so there's your formula for the perimeter. And what about the formula for area? Yep.
Length times width.
Area is length times width. All right, now, if you were to graph these, you might think of it more with like x and y if you were going to graph them. You might think of like 2x plus 2y, x times y. What would that top one look like if you graphed it? What shape would it be?
Linear?
Yeah, top one is linear. Okay. If you were to graph that, get y by itself, you could get that top one in y equals mx plus b form. How about that bottom one? is that one linear?
Is it like is it gonna have like, you know, so the parabola, how like the curved like cup thing? So is it gonna have the weird exponential thing where like it goes like up?
Yeah, it's gonna have a curve to it. Yeah.
Oh, there's gonna be an asymptote.
Right, you're gonna have two asymptotes in that. You're gonna have a vertical and a horizontal, right? As x, if you get y by itself, it's gonna be y equals 300 divided by x. So what I'm trying to get at here is one of these is gonna have a curve to it, maybe something like that, and the other one is going to be linear. Specifically, it's gonna be linear with a negative slope, because if you get y by itself, you'd have to subtract the 2x to the other side. So it's linear and it's a negative slope. That means we could get two answers to this problem if it lines up just right. And that's the concept I want you to understand here, that there could be two different answers. Any question? We're not solving for the answers yet. Okay, we're just setting up the system. Okay, I'll stick with using L and W because we're not actually going to graph it. We're going to solve it algebraically. But if you were going to graph it, you'd probably want to switch to X and Y. So the two methods that I'm going to show you how to solve systems, substitution and elimination. Substitution's okay when you have two variables, it works out. When you start to get into three variables, substitution's not really the best way to do it. It starts getting confusing. So that's where we want to switch over to elimination. Elimination also works for two variables, okay? But it's a little easier to do elimination for two, but it's still the best thing to use. Out of what we're going to learn today, it's still the best thing to use for three as well. All right, so now let's look at how do we do substitution. So the main idea with substitution is you need to pick one of your equations and solve it for one of your variables. So for step one, in a typical problem like we're doing, you have four choices. You can solve the top equation for L, you could solve the top equation for W. You could solve the bottom equation for L or the bottom equation for W. You want to do the easiest one you can. So once you get a variable by itself, you're going to take that information and you're going to plug it back into the other equation. By the end of step two, you should know one of your answers. Which one you know, it depends on how you did step one. Then, once you have one of your answers, you're going to take that answer, plug it back in, and then you'll have your other answer. The number of steps that it takes to solve systems of equations starts to go up very quickly when you add more variables. So for example, when you have a two-variable system and you solve it, and then you have a three-variable system and you solve it, a three-variable system isn't just a few more steps, it's a lot more steps. Okay? And then if you go to a four-variable system, now it's a ton more steps. It's not that the steps get harder, it's just the number of steps goes up very quickly. So when you start to get into something that's like 5 or higher variables, even elimination is not going to be that doable by hand. We got to switch over to maybe using something else. But I would say up to 3 or 4 variables, you can still handle elimination by hand in a reasonable amount of time. More than 4, we got to switch to maybe like a computer or something you could do on the graphing calculator. Someone have a question?
Yeah. For like all the steps, all the complexity and everything for like the 4 or more, is really like a simple formula to like, I don't know, like narrow it down. Because I remember that for, I can't remember how long ago it was, but there was something that we used T for like the number of the thing or number of things, and then use that like in the formula. So is there anything for that, like solving like stuff that has like a lot of variables, like having a just simple formula?
Like figuring out the number of steps it's going to take?
No, but like do it like no, somehow simplifying all of those steps somehow just by knowing how many variables you're trying to find.
No, there's more of what they call like algorithms to figure these things out. So the goal, especially when you're doing it like on a computer, is how fast of an algorithm can you come up with to solve the problem in the least amount of steps possible. And the problem is sometimes what makes sense to a human brain
doesn't make sense to a computer brain.
Right, so you can sometimes do things on computers that people would never think to do steps like that, but it's fast. So the methods that computers would use to solve these systems that start to get really complicated probably wouldn't make sense as steps that humans would do. So, but that's an area that they're always trying to improve. Can they solve a system faster and more efficiently than what they already know how to do? All right, so let's try to solve this one. We're going to use substitution. What equation would it be better to work with? Should we work with the top one or the bottom one?
I said the bottom one.
Yeah, we should work with the bottom one because we can get a letter by itself in one step. What letter do you want to get by itself?
L.
L. Okay, so in the bottom, if you get L by itself, can someone tell me what do you get for L? Yeah? 300 over W. Okay, now, we've got 300 over W. What do we do with that information?
You plug it into the top for hours.
Yeah, plug this back in to the other equation for L. So you're going to have 2, and then L is 300 over W, plus 2W equals 100. What's 300 over W times 2? $600 over W plus 2W equals 100. All right, so now we have just a W. After you do your substitution, there should only be one different letter in the equation. You may see that letter more than once, but it should be the same letter. All right, any thought what we're going to do next? Yeah?
We might need to do like a square root thing after we
No,
multiply
not a
by.
square root.
Well, like, I mean, the thing is, if you multiply it by W to both sides, then you would need to apply the W to everything. So I mean, you have to apply it to 2W, making it 2W squared.
Okay, so what would you get if you multiplied everything by W?
You would get 600 plus 2W squared equals 100W.
Okay, and what kind of equation is that now?
That looks like the x squared plus bx plus c equation, which has the two factoring things, and you can solve for 0.
Yep, and so what do we call that kind of equation?
Quadratic.
Yep, it's a quadratic. And how many answers can a quadratic equation have?
2, 1,
How many?
1. Sometimes there's 2. It can vary.
How many answers at most can a quadratic have?
It's like 2, 1, and 0.
Yeah, it could have 2, 1, or 0. So remember I showed you a graph earlier with a negatively sloped line and a curve and it hit it twice? That is one potential thing that could happen. Okay, we won't know until we solve it. What do we generally get a quadratic equal to when we're solving it? Yeah,
0.
so we're going to get it equal to 0. Before we continue on with whatever method we're going to use, there's something we could do now.
simplify?
Yeah, how could you simplify it with that?
Divided by 2.
Yeah. If you divide everything by 2, just makes the numbers a little smaller. Okay, so if you were going to try to factor it, you'd be looking for two numbers that multiply to give you 300, and then add or subtract to give you 50. Well, you're not going to find nice numbers that do that. So how else can we solve an equation like that if you can't factor it?
Quadratic formula.
Yep, so we're going to do quadratic formula. Negative b plus or minus the square root of b squared is 4ac all over 2a. So we're going to simplify that, and then we have to start to look at the answers and see if they make sense. We're solving for w. W stands for what?
Width.
Width. And width is a distance. So what do we know about distances?
Absolute value.
Right, they got to be positive. So if we ever end up with a negative, that answer doesn't make sense. I'm not saying you will end up with a negative, I'm just saying if. All right, so 50. What's 2,500 minus 1,200?
It's
1,300.
What is it?
1,300.
Yep, 1,300 over 2. All right, now we need to see what that comes out to.
Would it be proper for you to say 25 plus or minus square root of 1,300, or would you have to say it 25 plus or minus square root of 1,300 over 2? Like,
You'd have to leave the over 2, because the 2 has to go into both.
accommodate that?
So 50, let's do plus the square root of 1,300. Let's just get that out of the way, and now divide it by 2. So that is one answer for the width. It did not come out negative. 43.02, we'll say 028.
It can't be the other one because the other one before it would turn out negative.
You think the other one would turn out negative?
I'm pretty sure it would.
No, because if it's increasing it by 36, 36 is not bigger than 50, meaning that it like can't make it negative.
So 50 minus the square root of 1,300 is still positive. So that means this problem is going to have two solutions. So 13.94, don't forget I didn't divide by 2 yet. So the other answer for the width is 6.972. Now, not every system of equations comes out to be quadratic. Some don't. I just gave you one that did. Okay, so we got our widths. We need something else. We're not done. We need our
Does
lengths.
that mean we're gonna have 2 lengths?
Yeah. So we have to find L1 and L2. So these are going to be our two answers. All right.
I have a width that we can do this
Yep, how do we get the L1 and L2 quickly?
by using the 300 and the length times width. We can divide 300 by the width that we've already gotten,
Yep.
and we'll get the length.
So take 300, divide by your width, and you'll get your length.
And if we do it for both of them, it's
Yeah, watch what happens when you do the first one. 300 divided by 43.028. 6.972. So then if I take 300 and divide by 6.972,
it would be the other one that we have.
the other number, yeah, 43.028.
Does that mean we only have,
So we technically, we do have two answers. Okay? These are two different, if you think of these as coordinates, 43, 6 and 6, 43 aren't the same thing. Okay, they are different. In terms of the rectangle, what that means is one rectangle we're looking at this way, and the other answer we're just looking at this way. So it's a rotation, 2 answers. Right, but there are 2 answers. Any question on how we got the 2 answers? Yes.
Kind of exact same question I had about the hyperbolas. Would it ever be more rotated? Like, would it ever be anything other than the 0, 90, 180, 270? Like, would it ever be like a 45-degree angle or something?
No, we're just really viewing the 2 rectangles as horizontal and vertical.
Oh,
Yeah, I mean, I guess we're not even really viewing them that way. We're just saying we have one rectangle with a width of 43 and a length of 6.9, and one with a width of 6.9 and a length of 43.
okay, so it's not like rotating, it's actually.
You could visualize the rectangle however you want,
Yeah.
but those are your 2 answers. Any question on that? Okay, so that's substitution, and it turned out to be a quadratic. Okay, let's try this one. If you get y by itself in the top one and graph it, what shape would the top one be?
Linear?
Linear. How about the bottom one? Linear. Those are 2 linears. Okay, so when you draw 2 lines, can they cross? If they're different lines, not the same line, but if they are different, can they cross in more than one spot?
No.
No. Not unless they were the same line, but I said different. So 2 different lines can only cross in one spot. Let's see if we can figure it out. Which equation here would be the easiest to work with? You got to get a letter by itself. Yep, and which variable would you get by itself? Yeah, I would get y by itself. Okay. If you get y by itself in the top,
It's going to be
what does it equal?
2x minus 5. Or negative 2x plus 5.
Yeah. If you do it in y equals mx plus b, it's fine. We're not really worried. You got to get y by itself. So if you said 5 minus 2x, that's okay. Or negative 2x plus 5. All right. Now, what do we do with that?
Plug it into the second equation.
For which letter?
Y.
Yep, plug that in for y. And when I plug it in, I'm going to want to make sure I use certain symbols here. What symbols do I want to make sure that I use?
Parentheses.
Yes, I got to use parentheses because this is a distributive property. Okay. So it's 3x plus 2 times whatever you fill in for y. Well, we're filling in a binomial, so it's going to be negative 2x plus 5 in parentheses. So you got to distribute. Okay, equals 2. Okay, so solve that. We get negative 4x plus 10. Okay, what do you get when you combine your x's on the left? Yeah.
Negative 4x plus 10. Oh, sorry. You get negative x plus 10.
Negative x.
I was looking at parentheses.
And let's move the 10 to the other side at the same
Negative
time.
8.
Negative 8.
Ending in x equals 8. Which you can plug in to the top equation, the new one, the negative 2x plus 5. And you can find that y equals negative 11.
So fill that back in. So we get negative 2x plus 5, and that's negative 16 plus 5. Yep. So a couple different ways you could write your answer. I might have it set up on Edulastic where it's 2 boxes, like this, and you just fill in each box. Or I could set it up as a coordinate, and you just write your answer with parentheses and a comma. Now, we said that these are both lines. So if you drew them, what would be happening at the point 8, comma, negative 11? Yeah, that's where they're intersecting. Yep. And that is the only point where they're intersecting, because they're lines. So any questions on that? So if I was teaching substitution in Algebra 1, that's probably the first one I would have done. I wouldn't have done the quadratic first. But we should be pretty comfortable with either one of those. All right, elimination. So elimination is what a lot of other methods are based off of because it's more efficient. Okay, it's easier to solve more complicated problems with elimination. So we're going to learn elimination in a way that makes sense to, like, hopefully makes sense to like our brain. But there's ways that you can do shortcuts with this that you never even imagine, like a human doing, to make elimination really fast on a computer. All right. So the idea of elimination is you have two equations you're trying to solve, and you want to make one of the variables cancel out. And the way you get them to cancel out is you have to line the columns up and make the numbers the opposite. So for example, if you had 2x plus 5y equals 7, and 3x minus 5y equals 4, that's a perfect problem for elimination. Because the 5 and the y with the top, and the negative 5 with the y in the bottom are opposites. So when you add the columns up, the y's would cancel out. Now, it might not always line up that nice. You might have to use what's called a linear combination to make things cancel out. So an example of that would be 2x plus 5y equals 12, and 8x minus 3y equals 4.
Isn't that called systems equations?
Yep. So now you don't have any numbers that are opposites. But does anybody see a letter that if we multiply an equation by something, we could eliminate this letter? What letter do you think I'm focusing on? Yeah?
Oh wait, letter on. Wait,
What letter?
actually,
What letter?
couldn't you do 2x? Like,
So what letter are you thinking to eliminate?
X.
Yeah, x is the easier letter to eliminate here without worrying about using fractions. You generally take a smaller number and multiply it by something to make it the opposite of a bigger number. So what could you multiply the top equation by? Yeah?
-4.
Yes, that's called a linear combination. If you multiply the top by -4, it's a multiple of the original equation. And then it would make the x's cancel. All right, so that's the idea of elimination. So let's try that. We'll do it on a 2-variable. And then when we get to 3-variable, this is the only method we're going to use. We're not going to do substitution in 3.
I have a question. When you do like -4 for the whole equation, does that affect like the answer? Like,
No.
would you have to? Okay.
No. Multiplying an equation by a constant doesn't have any effect on the answer. Easiest way I could show you that is if I said, all right, I want you to solve this equation, or multiply both sides by 10 and solve that equation. Is there any difference in the answers?
No.
X is 3 in both cases. Even though this equation is 10 times as big, it's just a multiple of this one. Yep. So in the problem I showed you earlier, you had to multiply that top equation by a number. Well, you might have to multiply both sometimes. Depends on the problem. So let's look at this one. 2x plus 3y equals 5. And -3x plus 5y equals 21. There really isn't There isn't a way you can just multiply one equation by a number that's not a fraction to eliminate a letter. So what we want to do then is, let's focus on one letter, either x or y. I need someone to tell me which letter. Yeah?
Can we focus on x
Okay.
and multiply the top one by 3 and the bottom one by 2?
Okay, yeah. So if we're going to focus on the x, then what I generally do is look at the two numbers and find what the product of them is. Okay? The product of them is 6 or negative 6, however you look at it. So that means you need to make one of the x's a 6, you need to make one of the x's a negative 6, and then they'll cancel. So you said to multiply the top equation by what? 3. So what I'll do is put a 3, show that we're going to distribute it, and the bottom equation by 2. Okay, so we're going to create a linear combination of both equations. What will the top equation become? Yeah.
6x plus 9y equals 15.
6x plus 9y equals 15. And how about the bottom equation? Yep.
Negative 6x plus 10y equals 42.
Okay. Now, one thing we should have checked, but we didn't need to. The x's should be lined up in a column, the y's should be lined up, and then the constant should be on the other side. Okay. It was already set up like that for us. Okay. So now add your columns up. What's 6x plus negative 6x? 0. So that's gone. 9y plus 10y is 19y. And 15 and 42?
57.
So what's y? 3. Now to get x, you do it the same way you would have done if you would use substitution. You take the answer you got for your first letter and plug it back in. Is there a certain equation that we need to plug the y back into? Is there a certain equation that we need to plug it back into?
I think the top one doesn't have the negative.
So it doesn't directly answer my question. Yeah? You can plug it back into either. You do not have to plug it back into the top or the bottom. Either equation. The next question is, which one is easier? So then you might say, well, the top one. Yeah. Okay. But the top one, I would plug it back into that one. And we're going to plug in 3 for y. So we have 2x plus 9 equals 5. So 2x will equal
Negative 4.
-4. So x would be
-2.
-2. Yep. So x is -2, y is 3. Any question on that? So that's a basic kind of elimination problem. So I want to think more about what can happen when you're solving a linear system. Okay, so think about what can happen when you draw 2 lines. You draw 2 lines. What's one thing that could happen when you draw them? Yeah?
They could cross
They could cross how many times?
once.
Could cross 1 time. What else can happen when you draw 2 lines? Yeah?
They cross infinite number of times because they're on top of each other.
Okay, if they're exactly the same line, yep, they cross infinitely many times, yep.
And not cross at all if they're parallel.
Right, and they could not cross at all if they're parallel. So what that simplifies to is having one solution, no solution, or infinite solution. One solution, no solution, infinite solutions. So far, the 2 variable problems we've solved have been one solution. Okay, so let's try one of those other cases. We'll do it with two variable, and then we're going to finish up with solving a three variable. Let's try this one. Looking at this one, are you going to have to multiply both equations by a number, or could you just multiply one equation by a number?
One.
Yeah? Yeah, you could just do one. Right? So let's pick a letter we want to focus on. What letter do you want to try to eliminate, Sam?
X.
Okay, we're going to eliminate x. Which equation are you going to multiply, top or the bottom? Okay, so we're going to multiply the top. And what are you going to multiply the top by so it's the opposite of -6? 3. Okay, so let's write these over. Nothing's happening to the bottom. And the top is going to give us 6x minus 9y equals 15. Okay, so let's add them up. What do we get on the left side when we add everything up?
Doesn't it all cancel?
It all cancels, so what are we left with?
0.
Yeah, we're left with 0. And what do we get on the right side? 25.
Which is not true.
That is not true.
No
Correct.
solution.
So that means it's a no solution. So the way you can tell if it's going to be a special case, no solution or infinite solution, you go to solve the problem, all the letters cancel out. Okay, when all the letters cancel out, at that point the math is done. You need to look at the statement that you have. If you end up with a true statement, that would be infinite solutions. If you end up with a false statement, that would be no solution. So what would these lines look like if I drew them? Yeah,
Probably parallel.
they would be parallel. They would have the same slope, but they would have different y-intercepts. Yep. If they had the same slope and the same intercept, then they would be the same line. Okay? And we would have gotten a number on the left and a number on the right that would equal to each other. Like 0 equals 0. So any question on the no solution case or the infinite solution? I have one I can do, but I was going to skip to the 3 variable. So any question on what the infinite solution would look like? Okay. Now let's look at 3 variables. The way that I'm going to explain how to solve the 3 variable system is with elimination. I'm not going to say that it's the most efficient way to solve 3 variables, but it's probably the simplest. But simple doesn't always mean quick. It just means it's easy to understand. There are better methods for solving 3 variables, specifically if you start using a matrix. Okay, if you use a matrix on the graphing calculator, we can start to do some of this really, really fast. That would have been what we learned in section 10.2. Okay, but we're just not going to get to matrices this year. All right, so to solve a 3 variable system with elimination. First of all, we're going to pick a variable to eliminate. And we need to eliminate it in 2 different equations. Not just one. We have to eliminate it twice. So looking at this example, there is definitely a certain letter that I would try to eliminate by multiplying one of these equations by something and then adding it to the other.
Wait, can you repeat that?
So
We're multiplying and
we're going to have to multiply one of these equations by a number. Then we're going to add it to the other equation, and one of the letters is going to disappear. And we're going to do that twice.
So
Anybody? Yeah.
Wait, so you're saying like the result of, let's say, if we were to call the first equation A and then B, C, so you add A and B, and then the result of that is you do C and then the result.
So you're gonna well, let's call them like 1, 2, and 3.
Yeah.
So we'll call this one equation 1. This is 2. This one's 3. We're gonna pick 2 equations to combine together to get rid of a letter. Then you're gonna pick 2 different equations to combine together and get rid of the same letter. So did anybody think they see what letter would be easy to eliminate here? Yeah?
Multiply equation 2, multiply equation 1 by 2.
So what, they just want a single letter. What letter? Well, we could eliminate Z. I would say that's the second best choice for a letter to eliminate.
Why then? Because it has.
I wouldn't do Y. We're gonna end up with all kinds of fractions.
Can you multiply by negative?
You can multiply by a negative. But what letter here would be the easiest to work with because of its coefficient? Yeah, X. In that third equation, you have an X that has a 1. So it's very easy to multiply equation 3 by a number to make it the opposite of this and then the opposite of that. So I would probably try to eliminate X in equation 2 and then eliminate X in equation 1. That's probably what I would do. The Z would be okay because the Z in equation 1 is a negative, but I would rather work with a +1 coefficient than I would with a -1. It's not that much harder. But. Okay, so you're going to pick a variable, and we're going to eliminate it in 2 of the equations. Once you do that, you're going to have turned the problem into 3 equations and 3 variables, down to 2 equations and 2 variables. So after step 1, it's going to be just like the problems we've been doing so far. Then take those 2 equations and eliminate another variable. Now you're going to be down to a single letter, and you can solve for that letter. Once you solve for your first answer, the other answers are easy to get with substitution. You take the first letter you solve for, you plug it back in. That gives you the second letter. Then you take the first and the second letter, plug those back in, and you get the third letter. So we still use substitution at the end, but we're doing substitution purely with numbers at the end. Right? We're not doing substitution like we did at the beginning. We're just plugging numbers back in. All right, so as far as the notation, anytime that I write down, let's put those over there, a number that's circled, that's going to represent an equation, okay, just so we know which equation we're talking about. All right, so what letter did I suggest we try to eliminate? Yeah, okay, we're going to try to eliminate X. And what 2 equations do you want to use first to do that?
3 and 2.
3 and 2. Okay. So we're going to use equations 3 and 2 and eliminate X. So the first thing I'm going to do is just copy down equations 2 and 3. So 3x minus 2y. 2z equals 15. X plus 4y minus 3z equals -8. All right. So what do we have to do to eliminate x? Yep.
Multiply by -3. So
Multiply.
equation 3 by -3.
Yeah, we're going to multiply that bottom one by -3. Okay, what's going to happen to the top one? What are we multiplying that by?
Well,
Don't we just leave it?
Uh,
Result of X, don't we just leave it?
we just leave it, right? We're not really multiplying the top one by anything. Okay, we're just gonna leave it. So 3x minus 2y plus 2z equals 15. And what if you multiply the bottom by negative 3? What do you get?
Negative x.
Negative,
3x.
negative 3x.
And then negative 12y.
Negative 12y
And plus 3z. Oh no, 9z.
plus 9z.
And equals what? 24.
24. Okay. So now we're going to add those up. All right. What do we get when we add up everything that's on the left?
The x's cancel to 0.
Yep, so x's are gone.
That was what, negative 14?
So negative 14y
And then 11z.
plus 11z
39.
equals 39. Okay, so we put a box around that. And I'm going to refer to that as equation 4. Because I like to give names to things. Right, so that's equation 4. So we eliminated x. We need to do that again. We have to pick two equations and eliminate x one more time. You can't pick the same two equations. You just get the same answer again. So what equations could we use now to eliminate x? Yeah.
Should you use 3 and 1? Or?
Yeah, I would do, yeah, we could use 3 and 1. So let's use equations 3 and 1 and eliminate x. All right, so equation 3, we already got that one. And equation 1. 2x plus 3y minus z. Wait a minute, that copy something wrong? Equation 3 is x plus 4y minus 3z. I don't know what I wrote. X plus 4y minus 3z. So always make sure you copy it. Is 3z equals negative 8. Okay, so that was equation 3. Did I copy 1 right? 2x, 3y minus z. Okay, that looks good. Okay, how about Ryan? How am I going to eliminate x here?
By top by negative 2.
Yeah, multiply the top equation by negative 2. So, Ryan, if we do that, yeah, I think I said Ryan first time. That's you're good. It's, what do you get when you multiply everything by negative 2 there?
Oh, so it would be negative 2x.
Yep.
Negative 4y. Oh wait. No, negative 8.
Negative what?
8y.
Negative 8y.
And then 6z.
Plus
Plus
6z. Alright,
And then it equals to 16.
16. Yep. And Michael, what about the bottom?
It'll just be the same.
Stays the same. 2x plus 3y minus z equals negative 1. All right. And Richard, what do I get if I add up the whole left-hand side? Richard, what were you saying about that?
You get negative 5y
So negative 8y plus 3y, negative 5y
plus 5z
plus 5z
equals 15.
15. Perfect. Now, we could call that equation 5. But does anybody see something we could do to that equation? We don't have to do this, but if I see this, I usually do it.
Divide by 5.
Right. We could divide everything by 5 just to make the equation a little simpler. So negative 5y plus z,
And then 3.
yeah, equals 3. I was thinking of 5, sorry. So I would call that equation 5. Okay, so now we've got equations 4 and 5. Those are the two we're going to use now because it's down to 2 equations and 2 variables. And solving those 2 equations will give us the correct answers for y and z. Okay? We've eliminated the x out of the equation. All right, so now we're going to use 4 and 5. And we have to choose what we want to eliminate. What letter do we want to try to get rid of in 4 and 5?
Y.
Okay, so we could get rid of the y. So copy them down, make sure you copy them right. Negative 14y plus 11z equals 39. And negative y plus z equals 3. Okay, so you said y.
Multiplied by negative 14.
Which one?
Multiply the bottom equation by negative 14.
Yep. So let's distribute that negative 14 in the bottom. Max, what's going to happen to what's in the top?
It's going to stay the same.
That's just going to stay the same. Yeah, one of them always stays the same with these usually. They can both change, but I usually make it so one of them can stay the same. All right, in the bottom. What's the bottom equation going to turn into? Yep.
14y
So we get 14y. Yep.
minus 14z.
Minus 14z.
And then negative 42.
Let's see. Negative 14 times 3 is negative 42. Okay, so add those up. Y's are gone. Rory, what do I get for my z's?
Negative 3.
So negative 3z. And 39 minus 42.
Negative 3.
Yep, negative 3. Okay. So now we're going to have our first answer, but even though it's only the first answer, we're like 90% done. What's z going to be? 1. Z is 1. Now we're going to plug that back into one of the other equations. I would probably just plug it back into negative y plus z equals 3. Negative y plus z equals 3. Okay, what are you going to get for y? Negative 2. Yep. And now take those two numbers, plug them back in, and get x. Which equation do you think would be easiest to get x? Yeah?
The third one.
Yeah, because the x already has a coefficient of 1. So I got to write it down. X plus 4y minus 3z. So x plus 4y minus 3z. What was it equal to? Negative something?
A negative 8.
Negative 8. Okay, so x. What's 4 times negative 2?
Negative 8.
And what's negative 3 times 1? 3. Okay, -8 minus 3 gives me -11. And what do I get for x? How much? 3. Yep. So you can see once you got z, there wasn't that much work left. All the work is just getting that first answer, then you plug it back in. Alright, so that's pretty much how a 3-variable problem with elimination goes every time. So what I'll do is I'll put up the homework, and then while you guys are at lunch, I'll do a list of topics. Well, you know what? I can give you the list right now. Okay, so homework is 1 to 21 odd. And the test topics are going to be parabolas, ellipses, yep, 1 second, hyperbolas, and the type of questions I'm going to ask are all the questions we did this week. I give you an equation, you tell me about it, I'll tell you about it, you give me an equation, or you make a sketch. 1 second. 1 second. And then the last is going to be solving systems. Solving systems substitution, solving with elimination. 2-variable and 3-variable. Yes?
Are there going to be any like word problems?
There definitely could be a word problem with solving systems. There will not be any word problems with conic sections. But I could say, you know, like Jack sold student tickets and adult tickets to a musical or something. So, yeah. Someone else have another question?
How long page was it?
The homework is page 541.